All right, here we go, reviewing. So taking a look at the first problem here. We got a graph. So we got two graphs here. One is x minus 5. That's the straight line here. And square root of x plus 1. That's the square root graph here. So use the graphs above to explain why x equals 8 is a solution and why x equals 3 is extraneous. So if we take a look at the x-axis, you see at 8, the graphs cross here. And at 3, there is no intersection going on. So if you got both of these, 8 would be the solution because that's where it crosses. And 3 is not. So simply, x equals 8 is a solution because the graphs intersect at, or let's just say the graphs intersect there. X equals 3 is extraneous because they do not intersect there. Because they do not intersect. Or I would say the graphs do not intersect. Okay, that's fine. There. All right, cool. So graphing is really nice. Number 2, solve the equation below. Indicate which solutions, if any, are extraneous. So we're going to be solving this by hand now. So what I would do first is I would square both sides. Don't forget the parentheses. So, right, that means this equation changes to x minus 5 squared equals x plus 1. Remember, when you have a square and a square root, that eliminates that square root there. If I have x minus 5 squared, that means I got 2 of them. So let's write them out twice. And we've got to do the distributive property. So we're going to distribute it. All right, so let's write out what happens here. So x times x squared. X times negative 5 is negative 5x. Negative 5 times x is another negative 5x. Negative 5 times negative 5 is positive 25, which equals x plus 1. Now we want to try and combine like terms just to make our equation easier. So x squared. These two 5s will become a negative 10. Negative 10x plus 25 equals x plus 1. Now to solve quadratics like this looks like a standard form here. To solve something like this, we got to set everything equal to 0. So I'm going to subtract the x from both sides to make this 0 and subtract the minus 1. So subtract both of these. So subtract the x, subtract the minus 1. You're going to end up with x squared minus, again, 10 and another 1 make a negative 11x plus 25 minus 1 is 24 equals 0. So now what we're going to do is we're going to solve this. There's a whole bunch of methods for solving. You should always attempt to factor first before you try any of the other ones. So factoring means I want to change this back into something like that. So it's going to be x something and x something. I just don't quite know what. So that, remember when you're multiplying, we figure out that there are two numbers that multiply to this, and they sum to make this. They add to make that. So what two numbers could multiply to make 24? You've got 8 times 3, and also negative 8 times negative 3. Which one of these would make negative 11 if I added them? 8 and 3 is positive, so it's this one. So that's minus 8. All right, let's keep the color consistent. Minus 8 and minus 3. Remember that you're not done. You have to actually solve them. Meaning this part equals 0. X minus 8 equals 0 is one equation, and x minus 3 equals 0 as another equation. In that case, I got two solutions. I got x equals 8 and x equals 3. Now, with this, there is actually an extraneous solution. There are two ways to check for extraneous solutions. The first way is to take these numbers, 8 and 3, plug them back into the original equation, and see if they work. So I had two solutions, 8 and 3. Let's plug each into the original equation and see what happens. So original equation was x minus 5. So let's do 8 minus 5. That is 3. All right, what if I plug in the 8 right there? So I do the square root of 8 minus 3. Nope, not 8 minus 3, 8 plus 1. Because it's x plus 1, the answer is 8, so 8 plus 1. All right, they're both equal to 3. Awesome, so 3 is a solution. So that's real. What about if we try, 8 is a solution. What if we try 3? So we're going to do 3 minus 5. That's negative 2. And 3 plus 1. Square root of 3 plus 1. So now you got negative 2 and positive 2. Those don't work out. So I know that 8 is real and 3 is extraneous. The other way to check is to graph it. Put the original equation back in, x minus 5 in y1, square root of x plus 1 into the second one. That was a mistake, square root. So second square root x plus 1. All right, we're going to graph them and see where they intersect. So, where are they intersecting? They're intersecting right here. This is at 1, 2, 3, 4, 5, 6, 7, 8. And even if it's hard to see, like you know it's not 3 intersecting at 8. Okay, so there we go. That means that 8 is real, 3 is extraneous. The graph is a very powerful tool, so use that to help you out. All right, next one. So this problem asks to write 4 expressions that equal to 1. And they all have I, and there's a whole bunch of blanks in there. So what do we know about I? Well, I, we said was the square root of negative 1. I squared was negative 1. Well, what if I do I cubed? Well, isn't I cubed just I squared times another I, right? Because you got 1, 2, 3 i's here. So what's I squared? I squared is negative 1 times I, which is just negative I. So I cubed is negative I. What about I to the 4th? Well, I to the 4th, isn't that I squared times I squared? I squared is negative 1. The other I squared is negative 1. Negative 1 times negative 1 is just positive 1. So if we continue, this pattern keeps happening. I is square root of negative 1. I squared is negative 1. I cubed is negative I. I to the 4th is 1. And then after 5, it goes back up. I to the 5th, I to the 6th, I to the 7th is this, I to the 8th is this. I to the 9th is this, 10, 11, 12. So it turns out all multiples of 4 work. So I to the 4th, here's 1, 4, 5, 6, 7, 8. 8, 9, 10, 11, 12 would work. Yeah, you can go 13, 14, 15, 16, 17, 18, 19, yeah, even 20 would work. So all multiples of 4 would work here. Right here, we're going to finish the chart with a check for what type of number it is. So immediately you should know, remember, all numbers in existence are complex. That's because any number can be written as something plus something, something. It can always be written as A, which is a number, a real number, plus B with the I. So everything can be written out like that. Okay, well, that's not real, not pure imaginary. That's not real, also not pure imaginary. This is pure imaginary because there's only one term. It's 5i. There's no plus or minus anything else there. 6 is real, and if it's real, it can't be imaginary. square root of negative 3. Remember, this actually is just I square root of 3. Remember, you got to take the negative outside of the root. That means it's I root 3. There's one thing, pure imaginary. And 0 is real. All right, and with 5, perform the following operations. We want to make sure we write our answers in that form. So I'm subtracting, so we're going to subtract the like terms. 8 minus 3 is 5. 8 minus 3 is 5. 5i minus negative. If I have a minus and a minus, that makes a plus. 5i plus 4i is 9i. Not bad? This one here's a distributive property problem. You've got to actually do all of this. See, the 3 goes to both, the 2i goes to both. So 3 times 4, that's 12. 3 times 2i is 6i. Negative 2i times 4 is negative 8i. Negative 2i times 2i, well, 2 times 2 is 4, minus 4. I times I is I squared. Now time to clean this up because this is not pretty. So 12, 6 and 8, 6 minus 8 is 2, so negative 2i. We can also change this. Remember, I squared is negative 1, so change I squared to negative 1. In that case, negative 4 times negative 1 is positive 4, so we have 12 minus 2i plus 4. Right, and I'm not done. I need it to look like this, so let's combine the 4 and the 12 to just make 16. So 16 minus 2i. There we go. 16 minus 2i. So it's in the form, even if it's plus, like remember it's plus a negative number, so that works. All right. Here's the sometimes always. I don't particularly like this problem. It's a little too easy to cheese through. Give me an example where the sum of two complex numbers is a real number. And this is based off of the following statement that the sum of two complex numbers is sometimes a real number. So two complex numbers is a real number. Okay. Let's pick our actual a complex number, a hard one. So how about 3 plus I? That is a complex number because it has I and it's added to something. And let's add it to, how about 3 minus I? So if I do this, what do I get? 3 plus 3 adds to 6. I plus negative I, the positive and negatives will cancel out, leaving just the 6. So you had two exclusively complex numbers that add to 6. All right? Though remember, every number in existence is complex, so I could have just picked, I don't know, 2 plus 5 makes 7. Technically, these are two complex numbers making a real number, so it still fits this definition. For B, it has a given example where the sum of two complex numbers is not a real number. Okay, why don't we do 2 plus I plus 3 plus I. Why not? Well, what's 2 plus 3? 2 plus 3 is 5. I plus I is 2I. So here's an example. You ended up with a really ugly complex number. But we don't have to pick anything this difficult. All we need is two complex numbers that don't make a real number. So we could just do, I don't know, I plus 2I. I plus 2I makes 3I. Okay, that's another easy example. Now, how would our answers change if we subtracted or if we multiplied? Not really. All of these are pretty much sometimes. If you took a look at subtraction, remember subtraction is similar to addition. So it's also sometimes. So with subtraction, it's still sometimes. Subtraction is still sometimes. The difference of two complex numbers is still sometimes a real number. So the difference of two complex numbers is still sometimes a real number. For multiplication, it is also sometimes. It's still the same here. So in this case, when you're multiplying, we call this the product. The product of two complex numbers is sometimes a real number. A real number. I think with multiplication, there's a specific case that is pretty important. Remember, if we multiply, let's say something with I, right? Let's say, how about 2I times 3I? What happens when you multiply two things with I together? Well, 2 times 3 is 6, easy. I times I is I squared. Remember, if that's I squared, that is no longer complex. That changes to a real number. This is because the I squared changes to -1, meaning that's -6. So here's one of these sometimes examples where it is a real number. So put some focus on the fact that I squared is -1. Don't forget that fact. Right, moving along to the next one. All right, so one solution to the quadratic equation is, this quadratic equation is that. X equals 2 plus I. So remember, there's always two answers for every quadratic equation. When you've got a square, always two answers. So if you have 2 plus I, remember we forgot something here. There should be a plus or minus there. The actual total solution is x equals 2 plus or minus I. There's always two solutions. So notice the plus or minuses with the I. So if the first solution was, it had an imaginary part, the other solution should also have an imaginary part. So let's go through this list. The other solution is a real number? Absolutely not. We know it's the minus I, so that's not true. So I'm just going to cross that out. What about this one? X minus 2 plus I is a factor. This one is true. Remember, with any answer, all the answers can be written as factors like x minus this. So if you had, if P and Q were answers, if P and Q are solutions, then x minus P and x minus Q are the factors. So all the answers can just be written in this form. So yeah, if my answer is 2 plus I, well, guess what? X minus parentheses 2 plus I works. We already answered the third one. That is the other solution. The other solution is not a real number. That is true. It can't be solved. Well, it couldn't be solved before. It is solvable now because we are allowing use of complex answers. Finally, it's asked 2 plus I is a zero of the function. Remember, zero is just another fancy word for solution to quadratic, a quadratic equation. A quadratic equation. So 0 just means solution to a quadratic equation. That's also true. All right, cool. Let's go through 8, another graphing one. So we're going to look at this graph. Awesome. It never crosses the x-axis. So Jenny says there are 2 real solutions to this equation. Is Jenny correct? So no, there are not 2 real solutions. If there were 2 real solutions, the graph would actually cross, it would cross the x-axis. There is no crossing going on. Therefore, the 2 solutions must not be real solutions. They're probably complex solutions. So, is she correct? Nope. Jenny's incorrect. She is incorrect. Because the graph does not cross the x-axis. It does not cross the x-axis. If it doesn't cross, this means there are two complex solutions, not real solutions. This means there are two complex solutions. Not real ones. And they always come in pairs. If one solution is real, the other one has to be real. If one solution is complex, the other one must be complex as well. There's no such thing as one complex and one real. So if your answer is a number, real number, you'll get another number. Okay, so again, if it doesn't cross the graph, then they're not real. If they cross the graph, then they are real solutions. All right, moving along. All right, this is the entirety of the algebraic part now. So solve each quadratic equation below over the set of complex numbers. So because this is just a quadratic one, all of your solutions are going to be, all of your solutions are going to exist, and there can't be any extraneous solutions. So let's look here then. Well, you could have multiplied this out, but it might be easier to just subtract the 49. Because when you do that, you are allowing it to be solved by using square roots. Square roots, the nicest method to solve. So you got what? X plus 6 squared equals negative 49. So I'm solving using square roots. I can take the square root of both sides. But when I do that, what happens? X plus 6 is now by itself without the squared. And as always, remember, plus or minus. Whenever you take the square root of a square, plus or minus applies, because there was always two answers to deal with. Now, I don't like the square root of negative 49. I need to remove that negative, and we do that by putting an I on the outside. Though, what is the square root of 49? That's 7. So I can change this total thing into 7. I got x plus 6 equals plus or minus 7 times I. Remember, with square roots, I usually write the I in front just so it doesn't get confusing whether it's inside or outside the square root. But when it's pretty clear, then I just put it afterward. And subtract the 6. And I'm left with x equals negative 6 plus or minus 7i. So those are our two solutions. You could have also written like this. Either way works. I just prefer this this way because I kind of want something in front of the plus or minus. All right, awesome. So this was solving with square roots. I used square roots for this one. So using square roots. So if I'm solving with square roots, I want one thing on one side and one thing on the other side. One piece, one piece. For B, let's multiply this out first. This is kind of a disaster right now. And you absolutely don't have to draw the arrows. They're for people who need them. I'm just trying to cover all the bases in case anybody, some people need all of them. 5x times x is 5x squared. 5x times negative 2, negative 10x equals x times x is x squared. X times negative 6 is negative 6x. 3 times x is 3x. 3 times negative 6, negative 18. Let's combine the like terms. 6 and 3 can be combined. So that becomes the 5x squared stays the same, minus 10x stays the same, x squared. These two become negative 3x minus 18. Gross. And again, we want to combine, we want to set quadratics equal to 0. That's how we solve these things. So how do I do that then? Well, I want the x squared part to say positive. So I can subtract this one over here, this one to move it over here, and maybe move the 18. Doesn't matter which way you do it, because this way is this is definitely a quadratic formula 1. So I'm going to subtract x squared from both sides. I'm going to add 3x to both sides. I'm going to add that 18 to make it go there. So let's go vertically. Let's see. 5x squared minus x squared is 4x squared. Negative 10 and 3 make a negative 7x. That 18, that little extra 18 is going to come over too. And everything else cancels to 0. So now, this is a terrible problem. All I really want to be doing is using quadratic formula. So a equals 4. B equals negative 7, second number. C equals 18. So we're gonna just throw this all into the quadratic formula. You're not expected to memorize it. Right, quadratic formula. And I just kind of want to write it here, solving with quadratic formula. Just getting the answers the long and boring way. All right, so plug in A, B, and C. So in this case, what does x equal? X equals negative b, that's negative 7, which is a positive 7, plus or minus square root of negative 7 squared, minus 4 times a is 4, c is 18, and divide that by 2a. 2 times, what's a? 4. Right, this is pretty bad. Okay, well, okay, 7 is still 7, plus or minus. That's positive 49. 4 times 18, that is, and okay, what is that? Negative 288. How did I do that? I just used a calculator beforehand. 2 times 4 is 8. Right? This is not as terrible. It's still pretty bad. I can simplify it even further. X equals 7 plus or minus. That becomes the square root of negative 239 divided by 8. Now, remember, you cannot have negatives in the square roots, so that is not acceptable. I need to change it up. I have a little bit of space here. So I don't want that. I want x equals 7 plus or minus. I goes outside the square root divided by 8. That is your final answer. Oof. All right, so that was a quadratic formula one. All right, let's take a look at this last one. Okay. This minus 2 is kind of annoying, so let's get rid of that. 2x comes down, well, 2x squared, sorry. The negative x comes down. Negative 13 and negative 2 make negative 15, equaling to 0. So this could be done by factoring by grouping, but that's a pretty annoying technique. So you can just quadratic formula this one all over again. In this case, my a is 2. B is, there's no number in front of the x, but there's a negative, so that should be negative 1. No number means there's a 1 in front. C equals negative 15. So, time to put this all into our horrible formula with a's, b's, and c's in it. Okay, got a lot more space down here. So x equals what? Negative b, which is negative 1, plus or minus b squared, negative 1 squared, minus 4 times a, which is 2, times c, which is negative 15. Divide the entire thing by 2 times a is 2. All right, let's simplify this just to make our lives a little nicer. That's 1. Actually, that's a plus. 4 times 2 times 15. I know 4 times 15 is 60, and 60 times 2 is 120. Divided by 2 times 2, 4. All right, 120 plus 1, we know that's 121. That's just 1 plus or minus square root of 121 divided by 4. Now, 121 does have a square root value. If you can find the value of the square root, you should actually find the value. Don't leave it like this. Okay. All right. If your answer is like 2, for example, you don't want to say, oh, the answer is the square root of 4. That doesn't help anybody. So 121 changes to 7. No, not 7. I'm sorry, 11. That's not too similar. All right, great. So this is what I got. I'm not finished though. I need to write these out with both of their what both the solutions actually mean here. So for here, that means x equals 1 plus 11 over 4, and x equals 1 minus 11 over 4. All right, 1 plus 11, that's 12. 12 over 4 is 3. So my first solution, x equals 3. Whoa, that was pretty nice. Next one here, 1 minus 11, that's negative 10. Negative 10 divided by 4, that turns into negative 5 halves or negative 2.5. Either answer is acceptable. So x equals negative 5 halves or negative 2.5. With most teachers, we like fractions. They're more accurate, usually. All right, and that's it. Cool.